So, good day. I am Denzel Francis M. Casilian from 57079 Subsonic Aerodynamics. So, I'm going to report a aircraft characteristic curves. So, what is aircraft characteristic curves? Aircraft characteristic curves are graphical representations that show the relationship between key flight parameters and aircraft performance. These curves help engineers, pilots, and designers understand how the aircraft behaves under different conditions such as speed, altitude, or angle of attack. So, they are mostly crucial for performance analysis, stability control, aircraft design, flight testing, and also pilot decision making. So what are the types of characteristic curves? Number one is thrust required versus velocity. It shows how much thrust is needed at different speeds. This is used for power plant sizing and climb or cruise analysis. Number two is powered required versus velocity. This is similar to thrust required, but in terms of power, it is important for propeller-driven aircraft. Number three is lift versus angle of attack. It shows how lift changes with an angle of attack critical for stall and stability analysis. Drag versus velocity. It indicates how drag varies with speed, helps determine optimal cruise and range. And the drag polar plots drag coefficient or CD versus lift coefficient CL to show drag behavior at various lift conditions. So now let's move on to the problem. So the problem is we need to find the stall speed. An aircraft has a weight of 5,000 weight and wing area. We have wing area, maximum lift coefficient, air density at sea level. And now the question is, what is the stall speed of an aircraft? So now let's move on to solution. The solution is to lift equation in level flight. So lift equals weight equals 1/2 rows of v squared SCL max. So we need to solve for the v stall, the what you call this, the formula for this is 2w over square root of 2w over pass what you call this, SC PSCL max. And then the plug-in values is when you type this on your calculator, type square root fraction 2 times 5,000 over 1.225 times 16 times 1.5. And then the second one, if you input this on your calculator, the square root 10,000 over 29.4 is equals to 3 square root of 340.14 equals 18.44 meter per second. So now, as you can see here, the final answer on this slide 11 problem, when you solve 10,000 over 29.4 equals to 340.14. If you square root 340.14, the final answer will be 18.44 meters per second. So this is the final answer of our problem. V stall equals 18.4 meter per second. So this is the minimum speed at which the aircraft can fly before stalling. So that's all. Thank you.